Okay, now I'm going to move on to the cos graphs. The cos graph I think is a lot nicer than the sine graph because it's got, I think, nicer symmetry in it because of that line of symmetry in the middle. So we're going to use that to our advantage. If I want to do cos of minus 60 goes back there. And as I said, cos is an even function because of the line of symmetry in the middle. So if I reflect across to positive 60, then it doesn't change the value of cos. It doesn't change its sign, it stays the same. So nice and easy, cos of minus 60 is just cos of regular 60. Which from the diagram we've got is a half. Done. Okay, right, cos of 510. So 510 isn't on our picture, so we can't draw it on, but what we know about cos is that it's got a period of 360. So if I add and subtract multiples of 360, you just end up in the same spot on the graph with an equivalent angle. So what I'm going to do, I'm going to start with my 510, I'm going to take off 360 to get myself onto the picture at least. So that's the same as cos of 510 minus 360 is 150. Okay, going to clear these 60s. 150 goes in the picture. About there. And again, we're trying to get to the acute region down there. What we've got is we've got 60 degrees away from the 90. So then if I backtrack by 60 degrees from the 90, that puts me at 30 degrees. But by doing that, I've changed sign because I've gone from the negative angle, values of cos down here to the positive ones over there. So what I'm going to write down, cos of 150 is negative cos of 30. And then that's negative, and then what's cos of 30? It's root 3 over 2. And done. Okay, so there's other nice things you can use about cos, like we've just done. You've got it's even, you can remove negative signs if you need to, and you can move about by 360s as well. Right, the tan graph. Let's move that across over there. Tan graph looks a bit more funky, but it's I think it's just as easy as the cos graph. It's got a nice property, which is that all you need to know is that it repeats every 180 degrees. It keeps repeating that nice swishing pattern every time. So minus 225, I can put that on. That's halfway across there. So immediately I'm thinking of 45 degrees because of the gap that I've got either side. Right, we're trying to get across into here, into the acute angles, and see what's going on in terms of what's going on over there. So the first thing I want to do, I want to add 180 to get onto the next piece of the graph. So tan of minus 225 is the same as tan of minus 45. That's adding on 180 degrees. That puts me there. Then using the fact that tan is an odd function, just like sine is over here, if I'm at minus 45, then that value there is negative. If I go to positive 45, then you get the positive version of that number. So then, same as I've got over here, tan of minus 45 is just minus tan of normal 45, which is minus 1, because tan of 45 is 1. Okay, tan of 300, that's quite far off to the right, so I'm going to put 300 on over there. Okay, we're trying to get close to the middle, so I want to subtract 180 degrees. So that's tan of 120, that's the same. 120 is about here. Now you can try and reflect across this asymptote here if you want to, or what I might do as well is I want to go back to the negative angles, the negative acute ones. So I'm going to do this one more time. I'm going to go to tan of minus 60 with another 180 degrees. That puts me in there. And again, using the fact that tan's odd, I can take out that minus sign, put it at the front. Tan of minus 60 is minus tan of 60, because there's a sign change when you go across to the positives. And then what's tan of 60? It's root 3. So I've got minus root 3. And there you go.